Hello and welcome to this SMPTE Technology Committee meeting outcome summary. We do in fact have a special feature in this webcast. We have a guest speaker who will take us into a deep dive covering SMPTE registers. As Bruce Devlin, our Vice President of Standards, had mentioned last time, he is going to try every quarter to add a little bit of something extra, and this is the extra for us today. I am your host, Joel Welch, SMPTE's Director of Education. I know that everybody has a busy schedule, but it's very kind of you to join us. Most of you have been with us before, but if this is your first time, I'd like to give you some information about these webcasts. The committee meeting outcome summaries are a quarterly series of interactive webcasts. The interaction really depends on you. We ask you to ask our speakers verbal questions, or if you don't have a microphone or don't feel comfortable doing that, please type in your questions in the chat box, but I'll explain that in a moment. And the goal of these webcasts is to communicate to you, the people who are interested, the outcomes and the activities of the most recent SMPTE Technology Committee meetings. This last group of meetings was held in White Plains, New York, and it was quite a week, actually. These webcasts are also complimentary to everybody because we want everyone to know what wonderful work our volunteers are doing with standards development. And sessions are recorded and published for on-demand viewing on the SMPTE website at that URL, but also on YouTube. If you'd like to ask a question, please ask a verbal question. That makes it more of a conversation, more of a discussion, and I think adds a very good dynamic to the webcast. Again, if you don't have a microphone or you would just prefer to ask a text question, type it into the box. I will read the question to our speakers, and just so you know, we'll be taking periodic breaks throughout the presentation for questions. So please have your questions in the queue and ready to go when they come to you, because we'll be breaking frequently. SMPTE provides a PDF of slides used during the webcast in exchange for your feedback. As always, we'll provide a link to an online feedback form, and once that completed form is submitted, we ask you'll be automatically redirected to a PDF for downloading. And also, if you participate in social media, whatever the platform is of your choice, please feel free to post, blog, tweet, update your status, whatever, and tell people about this SMPTE webcast. Our handle is @SMPTE Connect, and the hashtag is #SMPTE Webcast. We have three speakers today: Bruce Devlin, Standards Vice President, Howard Lukk, Director of Engineering and Standards, and Mr. John Hurst, Co-Chair of TC30MR. And he is our very special speaker today, not to say that Bruce and Howard are not special, but John will be giving us that deep dive into SMPTE registers. So with that, I will turn off my webcam and turn the floor over to Mr. Bruce Devlin. Bruce, the floor is yours.
Thank you very much, Joel. And I have to disagree. I think John is very special. As you will hear, he will talk about interesting stuff, and I will force you all to remember thousands of document numbers so we can figure out at the end which one of the presentations was more interesting. But let's not forget Mr. Lukk, who will be providing witticisms and observations and other great things that I will have forgotten to say as we progress.
Yeah, I think we kind of call it color commentary, if you will. So away we go. And what a nice looking three gentlemen at the front, I must add. You know.
Absolutely. So this webcast is going to be covering the standards meeting that took place earlier this month at White Plains at the SMPTE headquarters of all places. And here is the corridor and the little reception that we have, which is the backdrop to this particular photograph. Maybe we should have had a little prize, Howard, to see if anybody can recognize the superstars in this photograph.
Yeah, there's too many to number in there of all the headquarters staff. And look, this was really, I think, one of those historic things. We had to prod our older guys to say, when was the last time they held a standards meeting at a SMPTE headquarters? And I think we concluded after much of investigation that none. So this was a historic first.
There was several cans of investigation opened, if I remember correctly, and consumed before we had come to that conclusion.
Absolutely.
So it was a fantastic event. We had 9 of the technology committees meeting, 12 subgroups at the headquarters, and the meeting outcome report is on that link. You can find it on the SMPTE website. The meetings took place over 4 days. There was one reception. Here's a photograph of the reception. And actually, looking at the back of my head, I think I'm going bald. I hadn't noticed that before. I should have used another photograph. Never mind.
Wait till you're done with your SVP role here.
Oh, yeah. I think I'll get a cardboard box out to hold all the hair that I'll be tearing out. So we had 53 on-site visitors, which was pretty much a capacity room. There was over 100 people took part in all of the meetings. There were 2 parallel streams took place, and in fact, there was, the conference room you see just behind the exit sign is where one of the streams took place. In the last quarter, SMPTE published 13 documents, which is it's keeping up on the sort of the record output from SMPTE numbers, which is good. And we currently have 160 active projects.
Yeah, we track generally about 60 to 70 documents per year, so we're on target pretty well to hit the same number.
So we're doing good. We're doing good. Now, I thought I'd just draw a slightly different take on the structure of standards. At the last webinar, I tried to give an overview of the process, so I thought I'd try and show the organization. Now, I'm sure that many of you on the call have taken the SMPTE standards operations manual to bed and read it page to page and tried to digest all the words and make sense of them. And if you haven't, I thought I'd draw this picture to try and save you at least the trouble of reading the first 5 or 6 pages. So the titular head of the standards organization is the standards vice president, which is me. And his right-hand man, and my right hand, as everybody knows, is about 6,500 miles long. To put my hand on your shoulder, Howard.
Yes.
So you are the currently in the OMs. It says engineering director, but we're updating the role to be director of standards and engineering.
Correct. And for those that haven't kept pace, of course, I will be transitioning out in a little bit, but I'm sure we will have another willing person to fill in that role just quite fine.
Indeed, and I'm aware that a press release is being made, although even though I know it exists, I'm not allowed to pretend I'm reading from it. So you'll just have to wait until next week to figure out who that is.
Stay tuned. It'll be exciting.
It will be. So the main committee that runs the standards is a thing called the Standards Committee. And this has a fixed, well, fairly fixed representation. So the 2 Stuckies, Howard and myself, are standing members of the Standards Committee, along with the previous Standards Vice President, who is Alan Lamshed. The SVP is able to appoint 4 standards directors, and I have done that and given them all various roles. Each of the Technology Committee chairs is also a member of the Standards Committee, and any subgroups which report directly to the Standards Committee. And currently we have one subgroup which is looking into software, specifically into software practices, how we store software elements, and how SMPTE is able to take software as part of a contribution towards a standard and get that to you, the users of the standards, in the most efficient way. We also have we have 3 SMPTE staff who are part of the Standards Committee, and outside this picture, any of the SMPTE Board of Governors who wish to join and listen in on the Standards Committee is able to do so. Did I miss anything out on that, Howard?
I don't think so, but I must compliment you on a very sexy looking chart here. This is quite nice.
I spent literally minutes coloring this in, I can tell you. It was the most fun I had in the last 10 days. So then we have the technology committees themselves. And again, I tried to do a slightly different take on the technology committees. I've color coded them. So the green ones are looking really at content, which is essence and metadata. The yellow ones are primarily applications of technology, and the grey ones are infrastructure and management. So in total, we have 10 TCs. We have a total of 851 members of the standards community. And in fact, it might be 852 because I can't remember whether I took that number before or after a new member joined. There are over 350 different companies represented in the standards community. As I've said already, 160 active projects. There are 95 active groups. And of those 851 members, I had a quick run through the data, which I probably won't be able to do after GDPR comes in, but I was able to figure out that there are 34 different countries represented in the standards community, which I think is quite impressive, actually.
Yep, we are a global effort, that's for sure.
We absolutely are. So I'm not going to read out the names of the standards community, of the technology committees, because I'm sure you've done that, and we will be going through them over the next few minutes. But first, for those of you who are listening, there's a little bit of homework. And for Joel, if he's been able to put it together, we're going to have a little poll towards the end. If you remember at the last webcast, we asked you the question, what could we do to make these more engaging? Would you like a deep dive? Would you like us to go across the technology committees and look at projects on a certain topic? Or would you like us just to review the work that's going on in the committees? And pretty much a third of you voted for each of the options, the true SMPTE way. So this webinar, we're going to have John Hurst, one of the TC30MR chairs, do a deep dive into registers. So the next one is a cross-TC look at a particular topic. So have a think while we're going through today's presentation, and we'll ask you at the end, would you like the next standards webinar, which will be in June, to be on HDR, high dynamic range, and that whole HDR wide color gamut ecosystem? Would you like it to look across the various committees on professional media on IP, SMPTE 2110 and all its associated bits of metadata, etc.? Or would you like it to be about IMF, the interoperable mastering format, which is kind of like the offline version of professional media on IP? So that's the question. Have a think about it, and we will be coming back to that one at the end of the webinar.
And for those of you that aren't familiar with our acronyms, TC is referring to technical committee. That's each one of the technical committees he was talking about before.
Thank you, Howard. So slightly different to last time, I thought I'd put in a slide which basically mentioned the new projects that have started up in the last quarter. I've arranged these by technology committee, and I'll come back to these various topics as I go through the various TC reports. But basically, we've had a couple of image compression projects start in TC10E. We've had a couple of projects start that cover additional frame rates in the digital cinema ecosystem, and those are in the digital cinema group. We've had a new revision kickoff of the way that IDA is carried in the DOI work within 30MR. Within the 32NF group, which is the Networks and Facilities group, there's a huge bit of ongoing work where we're basically adding HDR metadata signaling to just about every bit of network and infrastructure that SMPTE has standardized since year dot. So there's a bunch of different standards revision work that's kicked off there. There's also a couple of extensions to things like putting ST2110 in an environment where you're putting it across multiple ports. So say you're putting 8K UHD in an environment where an individual port doesn't have the bandwidth. So there's a new project starting off to be able to do that. And there's also a new project looking at how you put compressed video inside the SMPTE 2110 and SMPTE 2022 ecosystem. And the first of the volunteer codecs is the Derek codec VC2. There's also a new RDD about the translation between date and clock time and SMPTE timecode and how you do that deterministically to create a time label. Within the 34CS group, which is control systems, we've got a very exciting new project, I think it's very exciting, to do with microservices, looking at an overall microservices architecture. This architecture has been developed in Shanghai underneath the Hunan Broadcast company, and they've done a lot of work here, and they're looking to get this standardized, and we're extremely proud that they've chosen SMPTE to do this standardization. And of course, BXF6 is kicking off, and there's a revision to App2E taking place. Did I forget anything there, Howard?
No, but I think, it's fair to mention that we did have a new time label effort started off for I believe it's a standard recommended practice that's going on that's people should become aware of. It's not a new project as far as this meeting cycle goes, but it is a new project as of the last meeting cycle, and now they're starting to get cranked up and getting things going. So I'd encourage people into time labeling, especially for the production, post-production community, to maybe seek that out and get involved.
Absolutely, and we'll come across that a little bit later. TLX is the acronym to look for, TLX.
Exactly, thanks.
So let's kick off. The first TC that we'll look at is TC10E. I'll be going relatively quickly through these. Remember, please type your questions in. I will pause after each TC, but I'm going to go through these relatively quickly so that we can listen to the intellectual might of Mr. Hurst telling us about registers. So TC10E, as I've mentioned, is a couple of new projects. The VC6 codec is brand new, and those guys have had quite a few drafting meetings now. This really is a new sort of codec. It's really quite different to the traditional transform codecs that we're used to. It's marketed commercially under the name Perseus, but within SMPTE it's going to be known as VC6. And the first real big struggle that they're having here in the drafting community is trying to find the vocabulary and trying to line the vocabulary up with all the codecs that have gone before it. It's proving quite an interesting challenge because all the previous codec vocabulary is really quite JPEGy and MPEGy or wavelet-y, and Perseus or VC6 is really quite different. So that's proving quite interesting.
Got to give it a name.
Got to give it a name. So there's a bunch of projects still continuing within the SMPTE process. So we've got a revision to part of VC2, which is in process. The VC5 suite, which is the Cineform or GoPro codec, that's just about reaching completion now. Part 7 has got a little bit more work to do. And that might cause some revisions in other bits of the document, but essentially that's chugging along quite nicely. The reference display folks, they're having a revision to try and tidy up some of that bit of the document and add white points and other minor issue fixes. The document which specifies a lighting consistency index, in other words, how do you measure the consistency of lighting? I think that's a really fascinating piece of work. That's got as far as its pre-FCD review. So there's a bunch of comments that are coming out of that, and they're working on that. The mastering display color volume metadata update is in ST audit, so you should see that being published relatively soon. P3 colorimetry, P3, which everybody knows and loves, strangely doesn't have an underlying standard. And again, we're very pleased that SMPTE is the standards body of choice for that. The guys are making great progress drafting that one. There's a new standard on FS gamut, FS log characteristics of camera systems. That's having its first pre-FCD review to get some comments back before it goes into the due process balloting system. And we've got a new study group, which is kicked off looking on virtual reality and augmented reality. And if you're interested in that, please just join in. Howard,
yeah,
comments?
Again, for the acronym, kind of to break it down a little bit, the pre-FCD would be a final committee draft. That's really the technical stage that we look at the documents before they go on to their final viewing as a draft publication and then on to an ST audit and into publication.
So we'll just have a little pause and see if anybody has any questions about the work of TC10E.
Thank you, Bruce. Actually, no questions, but a comment, and I have some good news for you. Let's see. My teammate Roberta says that you will be able to report on the globality of the standards participants because she can anonymize the data, so you'll still be able to track how global the efforts are. I also want to tell you that through the magic of television and the fact that nobody can see what I am doing while you're speaking, we will in fact have a poll that we can go to when you tell me to go.
You're a top man, Joel. And I should also thank my daughter for doing the cartoon Bruce, because she's made me look young and slim and fit. So miracles of not having to stand in front of the camera. I do thank my daughter for that. Next committee is 20F, which is the Film Technology Committee. Film is that plastic stuff you shine lights through that is persistent and will last for 100 years. You remember that? They didn't have a meeting this time around, so no update from those folks. The next committee is TC21DC, the Digital Cinema Technology Committee. So as previously mentioned, there's a new project that's going to revise a few existing standards to put some new frame rates in. There's also been some updates to add some operational constraints to the DCP packaging and timed text file. One of those is waiting on some new magic numbers to come through the registers pipeline. So we will explain what waiting registers means later on, because John will actually demonstrate that to us. The timed text track file, you try saying that, that's in the publications queue. And there's a whole body of work going on to do with immersive audio. So there's a communications protocol, there's a reference method, there's a decoder spec, there's a track file layout, there's a bitstream specification, and all of those are undergoing various stages between drafting, waiting to figure out how the universal label structure is going to be, and some of them are waiting on other documents because they're all dependent on other standards being finalized. There's also been a couple of projects that have been closed and those documents published, and so as is the nature of things, when a project's closed, we shut it down, take it off the books, and if something needs to be reopened or revisited, we do that with revisions and amendments. Howard?
Yeah, just one more thing. It's not really on the list and it's not a project yet, but there is some effort now being put forward to work and straighten out some of the things in the kanji characters for Japanese coming up. So that'll be great to kind of tidy up that little bit of piece in digital cinema as well.
Absolutely. So any of you Japanese Ruby enthusiasts out there, feel free to join in those projects. Any questions on digital cinema?
There are no questions at this time.
You're going to keep seeing the cartoon me until someone asks something. 24TB, television and broadband media. So this is mostly covering ancillary services and how you get them between TV and broadband media. So there's been a suite of documents on AV synchronization and assessment. Those have been around for a little while now. Some of them are under 1-year review, and the engineering guideline of those is being drafted so that they're easier to understand now that we've deployed the documents and know where they're going. There is a body of work called the Open Binding of IDs. Specifically, how do you get an ID all the way from the creation of a TV program through to the consumption, and how do you get it from the creation of an advert all the way to the consumption of that advert? If you could have just one number that just told you about the, told you about the Game of Thrones-ness of a particular episode, wouldn't that be great for tracking stuff all the way through the system? So this suite of documents, the 2112 suite of documents, basically covers that. And depending on which one of the documents you're looking at, they're progressing nicely through. Some of them are nearly published, so there's a group that are in ST audit. A couple are in their pre-FCD comment resolution stage. And then one little document at the end, which is 2016 AFD and bar data. That's currently having revision, and that revision is being drafted, mostly to look at UHD characteristics of AFD and bar data. Howard?
Not much else to comment. I think we covered everything.
Cool. Any questions on 24TB?
We do have a question, and it's from AJ. He asks, what are the new frame rates for digital cinema?
What a very good question. Now, I'd love to say that I'd memorized all of those, but I haven't. So I do happen to have a document open on my screen at the moment, which I am scrolling through. It will take me just a few seconds to find that. Howard, if you want to tell jokes or something while I'm looking.
Yeah, so most of the stuff on the digital cinema frame rates is to incorporate legacy frame rates and other frame rates from television into the specification to kind of clean things up. So there's a bunch of different frame rates as they stand right now, but they're in separate documents. And so one of the things is to see if there may be a chance to clean that up, get them all in one document as well. So legacy frame rates, 8, 16, 12, I mean, take your pick. As you go into the other frame rates, of course, there's the 5994s, the 50s, all of those types of different frame rates that are in television as well too. And then get into high frame rate and you can keep going for a long time. And actually, Mr. Hurst is probably more of an expert than I am at this.
Thank you, Howard. I just wanted to add to, I think, what was a good summary, that there are actually no new frame rates being added. This is really just a roll-up of the frame rates that have been specified for some years, but were done after the main industry frame rates documentation-wise. So most equipment in the world is already aware of the available rates, although not very much equipment at all supports the archival frame rates.
Thank you, John. Handy to have a real expert on the call. So I'll assume that answered the question, and we'll chug on into 25 CSS, Cinema Sound Systems. If we didn't answer the question, feel free to ask a new one, and I'm sure Joel will let us know when we get to the next little break. So in 25 CSS, the main body of work that's keeping everyone busy is really to do with the immersive sound model, bitstream, and renderer. And those documents are making good progress. There's certainly a lot of active discussion within the meetings. I've sat in a few because it's interesting, and there's a really good meeting of minds. So the audio metadata and bitstream spec, those are having a pre-FCD review, and actually those documents are actually the linchpin for a bunch of other documents that you might have seen earlier waiting on SMPTE ST 2098, and they're going to be quite key to getting this whole new immersive sound, object sound, whatever you want to call it, getting into the food chain. So we've already published the audio channels and sound field groups document, a couple of documents waiting on the part 2 document, and the groups chugging on quite nicely. There's also an immersive audio implementation study group report, and that report is available to members of TC21DC. And if you'd like to read that report, please join up to TC21DC, and that report will be available to you. Any more observations from Howard or John on this one?
Not from my side.
I think you covered it.
Thank you. Any questions from the audience on 25 CSS?
There are no questions in the queue.
Thank you. So we'll move on to 30MR, Chair John Hurst, ably assisted by Mike DeValue. So 30MR is all about metadata and registers. There's a new project to revise RP 2079. There's a bunch of work going on UMIDs, unique material IDs. That work's been going on for quite a while, but really not much has happened over the last quarter. SMPTE ST 2088, the Essence Element Key Register structure, is a new register that we've been working on to register different Essence types, and that's currently undergoing review of the FCD comments that have been received. The amendment to ST 335, the metadata element dictionary structure, is just getting through ST audit and will be published relatively soon. And John will be giving us a demo later on. In fact, I suggest that we don't bother asking any questions here, because any questions will be ably answered by John later on with a real live demo, and he'll do it much better than me. So I'll move straight on to 31FS. Chair Bruce Devlin. Oh, what's he doing chairing groups? So this is the file formats and systems. There's a bunch of revisions to MXF documents. The constrained revision of 377, which is the MXF format, passed its FCD. It's now in pre-DP, is going to be happening relatively soon. There's a new document called the KLV encoded extension syntax, which is how do you create new binary objects in an MXF file. There is ST380, which is the MXF descriptive metadata scheme. That's undergone a revision to bring it up to date. That's ready for pre-DP review as well. There's also text-based metadata carriage in MXF 2057. That's how do you put XML into an MXF file, and that's used in IMF, it's used in dCinema, it's used extensively. Mapping MPEG streams into MXF-GC, that's been revised because of updates to the normative references. And although RDD44 is pretty brand new, because we then put ProRes into IMF, we had to make some small tweaks to RDD44, and so that revision is currently going through the committees as well. The work on the second part of the archive exchange format, AXF, that's currently chugging on quite nicely. Part 1's already been published, but part 2 is really about externally referencing bundles from the AXF main database. And finally, there's a revision of DPX, or sorry, a creation of a new part 2 of DPX, where we're looking here at how do you put high dynamic range inside DPX, and that's gone through one FCD ballot and is currently going through its second FCD ballot as we speak. In fact, I think that ballot either closed a couple of days ago or closes in a couple of days' time. So, any questions on 31FS?
There are no questions in the queue, but I do encourage our guests to post your questions in the question box, and please, please, please ask a verbal question. We'd like to have a conversation.
Yes, please.
And Bruce, look, you got out of a technical committee chair now. You found a new chair.
I found a new chair. You realize how easy that is to do? He coughed. The best thing about
we encourage folks to get involved in SMPTE standards and participate, and someday you might be able to have the privilege of being a new chair too.
Absolutely. And the best thing about the new chair, Fred, is Fred's young. He's really only done one significant project within the SMPTE standards, and it's been quite challenging. It's that he's doing the DPX revision project.
He's had a rough go at it. Yeah,
he really has. But he's not been put off. He's actually seen the goodness that could come out of standards, and he's willing to step up to be a chair. So little silent round of applause for Fred, because he's doing an awesome job. So the next committee is 32NF, Networks and Facilities. And as you saw from the opening new project slide, that this group has got a lot of work on its plate. They're doing such a fantastic job. So we talked briefly about the great big body of work, which is to add HDR signaling to all the existing transport standards that SMPTE has. And the majority of the new projects are covering those. We should also point out that there's still an existing body of work that's doing exactly that same thing. So one of the interesting ones is EG 2111, which is to explain how 3G, 6G, and 12G SDI interfaces work. And those are being done in the form of posters. So if you've just redecorated a room and you're finding it hard to paint an entire wall, I thoroughly recommend getting all 3 of these posters as soon as they're published, because these things are enormous and they cover all the interesting fine points of how to use 3G, 6G, and 12G SDI. They really are a labor of love by the committee, and I'm so impressed with what they've managed to produce with these things.
Yeah, a lot of work has gone into these things, and the first publication went out with the journal, so if you subscribe to the journal, you will get the other copies. So another reason to be a SMPTE member. Sorry,
Absolutely.
I had to pitch for a minute there.
Well, yes, I'm tired. I forgot that I should be pitching as well. But also, with your journal comes free wallpaper in the form of EG 2111 parts 2, 3, and 4. And again, they are big and they are very impressive and very enormous. And it just reflects that, you know, if you're trying to write down what SMPTE has done on one sheet of paper, you need a very big bit of paper, and that's just covering one interface.
Yeah, a lot of work, a lot of huge thanks to that group that's done some really heavy lifting and make it some really nice diagrams and wallpaper.
So next group is ruggedized SDI fiber connector. And again, we often forget that, you know, in SMPTE, when we're doing sort of the new age, sexy, new stuff that's coming out like IP transport, that we do the stuff that is made in their thousands and millions around the world, like a ruggedized SDI fiber connector. Those things are standardized by SMPTE. and it's currently going through SD audit, which means it's going to be published any day soon. Another body of the HDR wide color gamut signaling in the form of ST2081 and 2036 and updates to 292. Those have gone through the process and they're currently undergoing ST audit. Howard, what does ST audit mean again?
Sorry, a little slow on my mute button, but ST audit is the standards technology audit, basically, to make sure that everything is appropriate in the process, that nobody did some unfair games as they were working their document forward, didn't skip anything, didn't try to pull some fast ones. So we do all the checking in the process to make sure the process is complete, and that's done by the standards committee that Bruce was talking about earlier in the program.
And if I read the OMs and the governance manual correctly, apparently there is one physical human being who's responsible for preparing the ST audit and a different human being who has to go to prison if it doesn't work properly. Can you remind me which two individuals form those roles?
I can't care to comment on that one.
Can you? Well, I'll send you postcards from prison in that case. Okay. Good job, mate. Keep me out. So there's also a project on haptic tactile essence. That work on that has been paused and the plan is to resume soon. I'm looking forward to that one because if we can get tactile stuff all the way through the British broadcasting system, then I can actually sit and watch Blue Planet and have my sofa jump up and down when the blue whale bumps into the camera. Looking forward to that.
I thought it was really interesting. If you're going to go see the movies this weekend and you go see Ready Player One, there was a lot of haptic tactic stuff going on. Tell you, and they talked about it a lot, so it's going to be something.
If you're in the USA, go and reserve those seats now, folks. And if you're in the UK, well, good luck trying to find a D-box or equivalent haptic seat.
I'll spare my opinion of the film till later on after you've seen it.
But I'm sure the haptic tactile stuff is fantastic.
Yes, it was very good.
So more projects within 32NF. So there's pathological conditions in SDI and the digital checksum for use in HDSDI. Both of those kicked off their revisions at about the same time. But RP198 is so important that essentially the decision was taken to close the ballot, reaffirm the document, get it stable to get it used. And the revision, any changes to it can wait to a later date because the changes weren't important, but getting a stable document was. Whereas the pathological conditions for SDI, for those of you familiar with SDI, as I spent a lot of my youth doing, purple and green, that's still being drafted, or the revision is still being drafted. There's also a revision to the carriage of ANC packets in MPEG-2TS, and that's currently in its pre-FCD review, so that's being checked before it undergoes its ballot. And for the video over IP documents, these are making good progress. As you remember from last time, the main documents were published last time round, so these are kind of like the second wave of documents. So the transparent transport of AES3 is undergoing its pre-DP review prior to DP vote. ANC data, of which ST2022 Part 6 is also in scope. That's also levers off this particular document. That's undergoing ST audit, ready for publish soon. Timing of 2022 Part 6 is undergoing pre-FCD review. And there's a couple of revisions to 2022 Part 7 and 3, and those are undergoing their pre-FCD review prior to their ballot. I think this is the final page for 32NF. So there's some UHD SDI revision work going on, again to inject that critical HDR metadata signaling. There's a whole bunch of work going on in terms of testing ST2059 and ST2110. You can read the report on that interoperability testing on the SMPTE website, and there's more testing going on and more drafting going on those tests. And I wonder, Howard, if people were interested in that, is there anywhere within the next couple of weeks they could see this kind of thing live?
Absolutely. If you're at NAB, go check out the IP interop stand that's going to be there. I forget the official name.
Showcase.
It escapes me at the moment. The showcase, IP showcase. Thank you. Yeah, go check it out because there's a lot of interesting things. For those that aren't aware, this is kind of what would be the new TriSync, or if you're really old like me, it's the new Blackburst. So it is important to get up to speed on this stuff as you get into fully new networking broadcast plants, especially. and other people can find uses for it as well too. And there's been a huge amount of work by a lot of companies. It's a great effort, and boy, you can come up to speed pretty quick if you hang around that booth at NAB if you have the time.
And it's really exciting, the booth, because there's all sorts of hands-on experiments. It's a bit like a kid's science museum exhibit. So you can walk up, you can unplug an RJ45 and watch the signal disappear, plug it back in and watch it reappear again. You can do failover tests. So there's a whole bunch of, touchy-feely kids' TV stuff that you can play with. And
yeah, it's absolutely, it's real working gear using that standard. So it's been a huge effort by a lot of folks, and it's been really very, very successful, and really helped us speed up that standard quite a bit.
And Howard, remind me what TLX is again?
So TLX is something, this is a new time label for production and the post-production community to a certain extent, also broadcast community as well. But we've been going back and forth for quite some time. So after we've gone through many interviews, the time code summits, we've argued back and forth on what should a time label look at going forward. There's two projects basically going on. One was the RDD that was mentioned earlier, and then this project as well. I don't believe they're competing. However, heads up to everybody in production and post-production, you really should pay attention to this one and get involved, especially if you're on the technical side, because this is going to be the future of time code as you know it in production and post-production. I'm pretty sure of that. So it's exciting. It's going to give you some very new opportunities, especially for tracking and indexing metadata and keeping things where they should be. Get involved.
Absolutely. Thank you, Howard. And speaking of metadata, I should speed up a bit so that we give John a fair crack at his presentation. So data over AS3, which is the SMPTE, ST337 family. So this is the sort of data that we're trying to put on is things like the MPEG-H 3D audio streams. It's the audio definition model and the multi-dimensional audio, trying to put all of that stuff onto ST337. There's some interesting technology sort of left turns that were discovered, and I think we fixed all of those now, and that work, I hope, has been unblocked and is carrying on nicely. Any questions on the vast volume of 32NF work?
We do. Hurrah! Our guest Dan says, I do not know details on SMPTE and am looking forward to learning more. Curious if any SMPTE is working on color gamut volume.
That would be the 10E committee, and the answer is very much yes. Mixing those two words in the same sentence would cause all sorts of interesting technology comments from various people within the room who have their own opinions on how to use those two words in the same sentence. So rather than go into depth here, I'll let Howard say a couple of words, and then we might just take that one offline and give a bit of a tutorial. Howard.
Sure. I think the real answer is we work on a lot of different color volumes and gamuts and all kinds of things, but 10E is the place to pay attention to. So what I would do is encourage you not to go into in-depth diving down to the weeds, which we love to do. Try to check out the report for more detail in the 10E area, and we have quite a bit of people working on basic color volumes and how to handle them. Rec 2020, 709, of course, P3 is the other one. You've got Cap XYZ, a whole lot of stuff, but that's the committee to pay attention to.
Yeah, and there's a whole 2 pages in the report that you can download off the website that goes into 10E. And if that doesn't quench your thirst, join the committee or drop an email to Howard or myself, and we'd be happy to talk you through stuff. So the next committee is 34CS, mostly looking at control protocols. I've already mentioned the Media Microservices Architecture project. This is exciting because microservices are entering SMPTE, and also I believe it's the first Chinese-sponsored project that's entered SMPTE, which is extremely exciting. So we also have BXF6 coming through, and a thing called MDC, which is Media Device Control. There's some liaison work going on with the AES and AMWA on this, as well as the MDC documents having to return to working draft status to do a little bit more work to fix some issues that were found as a result of balloting. Any questions?
There are no questions.
I thought that might be the case. So final committee, but by no means the least committee, is 35 PM, Packaging and Media of Interchange. So we're currently revising App 2E to address some of the issues found on the IMF issue tracker, and I believe also to introduce some nomenclature for carrying HLG, hybrid log gamma. There's a bunch of other work going on. So there's a revision of one of the OPL macros that's in its publication queue. There is the snappily entitled Dynamic Metadata for Color Volume Transform, or basically how do you put dynamic color metadata into an IMF mastering ecosystem. So that covers things like the Technicolor system, it covers Dolby Vision, it covers 4 different systems. There is a vocabulary being created for the audio element and content kind. There's a carriage mechanism for the immersive audio bitstream. You remember that work was taking place also in 21DC, and sorry, 25 CSS. There is almost published the application that allows you to put ACES data into IMF. There's a thing called the sidecar composition map, which again is almost published. I reckon this will be out in about 3 weeks' time, just after the last day of NAB. I reckon that's what Murphy's Law tells you. And there's also an amendment to the IMF application 4, which is the cinema mezzanine, which is the law in France of all places. And because ProRes in IMF, that project finished, that project was closed. Any questions on 35 PM or any of the technology committees?
Yes, actually. Good friend Gary asks, could you talk about specifications?
I would love to, Gary. If we have time at the end, I will talk about specifications. I'll put that on my list. But I want to make certain that John gets a good go to do the deep dive. And if we don't talk about specifications, I will schedule something on specifications with you, Joel, so that we can talk about it, because it's still work in progress from SMPTE.
And I also think that, Joel, the specification should be probably a webcast in its own. It takes some time to kind of go through the whole process and explanation, and I think maybe that would be a fun one to do next.
I shall get one on the calendar.
Thank you, Joel. And thank you, Gary. Metadata registers. So I've just got 2 slides to kind of introduce John. So I just wanted to say some words. That we do actually have some procedures for putting stuff into registers, AG18. That's all you have to remember, but that's the procedure. And I just wanted to make certain that everyone listening is clear on the difference between a registration authority. So SMPTE as a body is the registration authority for a number of things, and John will be talking about some of the things for which we are a registration authority. Whereas the registry itself is the database or collection of databases or service or thing in which you store the data. And the data itself is often stored in things called registers. So the registry is a collection of registers. Not everybody uses that model, but we do. We also will talk about various classes of data. And if you're interested in those classes, those are documented in SMPTE standards. Have a look at SMPTE 336 for the root document, and other documents will spawn off that one. We might also talk about UMIDs, SMPTE 330, which is the Unique Material ID. And we might also mention XML namespaces. And if you're not familiar with XML, an XML namespace is just a way of differentiating between the possible meanings of an XML tag. And anybody who's tried to migrate their address book from Outlook maybe to Google knows that the word address can have several meanings, and you use namespaces to say that my meaning of the word address is the Google way, or my meaning of the word address is the Microsoft way. So it's kind of like a qualifier to tell you what you mean by a particular word. And if you want to sing along with John, or if you want to have a little play, this is the website you need, simptera.org. You'll recognize it because it says, welcome to the SMPTE Registration Authority. And there's fast navigation to all the various places that you might want to go down the left-hand side. And most of what we'll talk about is that one there. And with that, I will hand over to the expert himself, Mr. John Hurst.
Thank you, Bruce. Thank you, Joel. it's visible?
It is indeed.
We can see you.
All right. So thank you all very much for joining for this. I'm interested to see how it turns out myself. I'm going to be showing you features, talking about aspects of SMPTE technology that have been documented for a long time, but I'm going to be showing you technical features that have only been recently developed that make those structures and the rules around them much more easy to use, both as a developer of file formats and as a consumer of file formats. So to review kind of briefly the ground on which we're walking, key length value packets are the fundamental building block of an MXF file. They consist, as you can see highlighted on the slide, of a value that, a key value which is assigned, which is the subject of the registers, which we're going to be discussing today, a length that tells you how long the payload is, and the actual payload itself, the value. This very simple structure can be expanded in a hierarchical way in order to create very rich data structures of unlimited complexity. And so a lot of what we try to do in documenting and producing applications for this is to manage that complexity so that we can fulfill the requirements of the application without creating a data structure that's difficult to program against or expensive to use. So as I said, an MXF file is a, sorry, I put the slide in the wrong order there. An MXF file is a sequence of KLV packets, very simply. And so the technical details of consuming an MXF file consist of reading the key and reading enough bytes off to consume the value from the file. And then we can go look up in software what that key is and how to interpret the data that's inside the packet. So the keys that are in a key length value are the real subject of our conversation today. These are called universal labels, and we are going to be talking about the registers for universal labels that are maintained by SMPTE in its role as a registration authority. These universal labels are based on ISO object coding standards, ASN1, so they do have a normative structure. For the SMPTE application, this has been simplified somewhat. Most commonly, the keys that we use in our KLV packets are 16 bytes in length, and there are a variety of strategies for handing out these values such that they don't collide in the field. So for example, if we hand out a value that's going to be marking a packet that contains PCM audio samples, we want to make sure that that number does not conflict with any other number that has been issued in the past, such as one that might mark what the coding standard was for an image frame in a series of images. So this method of encoding a value was selected in the very early days of the MXF project. Actually, I think, Bruce, does it even precede MXF? Was it in AAF?
It was indeed in AAF, yes.
Yeah. So when we look at some of the sort of mind-smashing detail of taking common words and boiling down into little tiny strings of number, we have to remember that this stuff was invented by people who thought a 300 bits per second modem was a really cool thing to have at home in an era when 256 kilobit DSL was the new hotness that only a few people could get in certain neighborhoods. So there's a certain obsession with compactness and removal of redundancy that comes along with this entire endeavor. And so functional as it is, it can be sometimes difficult to learn about. And so please, I hope this introduction helps clear up any questions you might have had about how it works. And if there are questions that you have as we move along, please ask them of Joel. We're not going to actually dive into the total structure of how these numbers are assigned. For our purpose today, it's enough to know that they are typically 16 bytes in length, certainly always when they are the top level packets in an MXF file, and that avoiding collisions in these values is essential in making sure that we have an interoperable system with no unexpected operations on a remote end. Bruce mentioned namespaces before we started here. We can consider this UL space to be underneath of a namespace, and we'll actually see a little bit later how these values can be coded for use as uniform resource numbers as commonly used in web standards such as HTTP. So it should also be noted that KLV packets can be nested. A KLV packet may contain other KLV packets, may contain other KLV packets on down into the rabbit hole. And there, we'll talk a little bit later about one of the side effects that this encapsulation coding has when we get a little bit further into the presentation. So there are a set of databases within the SMPTE UL registers. We have our elements, groups, labels, and types. So I'll show in a moment how those relate to the KLV packet. But just briefly, elements are members of groups. Labels are values. They do things like describe image formats that are in use or audio coding formats and so forth. And types are the sort of intrinsic data types that all complex data structures are made out of. Strings and integers and universal labels themselves can be values, and so forth. Also, as mentioned by Bruce earlier in the show here, we are working on the 5th register, which is the essence register. That's going to be document ST2088, and it's currently in the FCD ballot resolution process. So hopefully we will see that soon within the community. So as I mentioned, the groups, elements, and types all have a meaning within the context of an MXF file. A group is a KLV packet that contains other KLV packets. And so when we take a data structure, for those of you who are familiar with various programming languages that allow you to collect data objects into a structure, the group is that sort of mechanism inside the MXF world. Then within a group, we have a set of elements that comprise the properties of that group, such as name, address, and telephone number, and an address book. So the elements are essentially the collection of elements comprises the identity of the group in terms of its internals. And then, of course, each of those elements has a type. Again, strings, integers, ULs themselves, compound types such as rational numbers, and so forth. And so each of these items in each of these registers has a universal label that identifies it. So when you are decoding a KLV group, there is a UL at the beginning of that KLV packet, and if you look that up in the groups register, you'll find out what kind of group it is. And when you open up that group, you will see that it contains a collection of elements. And for each of those, if you look it up in the elements register, you will find a UL that describes that element of that group and tells you what type it is, which is expressed in the form of a UL, which you can then look up in the types register, which will tell you what is that type and how to decode it. There are what I consider to be intrinsic types like integers, and compound types such as pairs of numbers or a UL paired with an integer. There are many examples of that we could see when we look at actual MXF data. And then not shown here are the labels and the essence, whereas group, element, and type describe the structural coding of the data. Labels and essence ULs are values. So if we had a KLV packet that had a type of universal label, then what we would expect to find in there is something that comes from either the labels or the essence register. Are there any questions before I move on?
There are no questions at this time.
Okay. I looked over the attendees list. There's a lot of experts here. I'm really nervous. They're not asking questions because they're saving them for the end.
Saving the really hard ones for you, John.
Just hope the tomatoes aren't coming.
So there is yet another standard, because that's what we do, called regXML, which is an XML representation of SMPTE registered data. So we talk about these catalogs, these databases, these collections, these registers, these sets of ULs, and we have to have a way to communicate them to each other in a form that's hopefully interoperable. And for years, that format was Microsoft Excel spreadsheets. The community made good use of those, and for a very long time, that was sufficient to handle the amount of work that was required, or rather was able to complete registrations in a timely way, given the amount of churn that there was on labels at that time. Most of that work, the early work of entering data into those tables, was the formative years of MXF, and the group of people working on that found exchanging those spreadsheets to be fairly straightforward. Also, at the time, there was not yet the idea of interoperability beyond using XLS. However, as we eventually do, we decide we want to interchange these things, and we want to do them in a tool-independent way. So regXML is an XML format for expressing registers. So when we, in a few short minutes, start to look at the contents of the registers support website, we'll see that regXML is used as the standard for formatting and presenting this information in its XML form.
And John, you're being too kind. Sharing spreadsheets got to be a pain in the butt.
Well, it did, and so the community banded together over the course of the last 3 or 4 years, and did the remaining work to finish off regXML and make it useful. Wrote open source software that I'll talk about in a little bit, in order to be able to support regXML and get people up and running without everybody having to perform an implementation. That project was actually sponsored by Netflix. It was very, very helpful to the community. And so it's sort of, not only was there the convergence of available technology, but there was also a strong wish on the part of several user communities outside the usual core MXF community who had adopted MXF and were anxious to perform registrations on a much larger scale than was ever possible with the Excel spreadsheets. So thank you, Howard, for pointing that out. So the main online resource, as Bruce showed us on his slide, and we'll go to in just a moment, is https registry.smpte.ra.org. Oh, actually, sorry. Bruce showed us the top of the SMPTE RA website. Registry.smpte.ra.org is actually where we're going to be spending our time with the register's maintenance website. So this is an authoritative publication of a regXML meta-dictionary. That is, 30MR prepares the regXML expression of what we believe the contents of the registers to be at any given point in time. When we take that through the usual engineering document process, a process that we recently codified also at the administrative guideline level with AG 18. And so we now have a complete end-to-end process for maintaining and publishing the set of ULs that comprise all of the registered entities and all of the SMPTE documents, as well as the private register spaces that have been secured by several organizations. We can look at those later on if we have some time. And so this meta-dictionary is published right now on an irregular basis as we work through the process. We are slowly moving our way toward being able to publish on a schedule that's shorter than 1 year. Our goal, and hopefully we'll reach that in the next couple of years, is to be able to publish this information on a regular twice-yearly basis. Also, before we go any further, I want to talk a little bit about this subject that I'm calling wildcards for a moment. When I showed you before that the KLV packets can be nested, and I discussed the obsession with making data as compact as possible that we inherited from computer engineering, best computer engineering practices at the time. There are several variants of ways to encode a KLV packet. The one that I showed you at the beginning of the presentation, where the UL is 16 bytes long, is a fairly inefficient. Again, if you're worried about space, you might think that it's a bad idea to use 16 bytes of UL and 4 bytes of length in order to encode a 4-byte integer value. So there are a variety of mechanisms or alternatives to coding a KLV packet that do not use the standard 16-byte UL. The two that are most interesting in MXF are packs, where the the UL itself is actually eliminated in front of each of the elements inside the KLV packet. And tag length value packs where the 16-byte universal label is actually represented through a local lookup table as a 2-byte value. And so this allows a much more compact representation of the data. Every item in the file is still ultimately traceable to a 16-byte UL value, but these inferred or abbreviated representations allow the file to be more compactly represented. The reason I bring this up right now is that as we're moving through and looking at the some of the ULs, especially the groups ULs, we'll see from time to time that the value that is in the register is not actually the value that will appear in the file. There's a placeholder value in the register, and when you read the packet from the file, it tells you by a value that's inserted in place of the placeholder whether this is a fixed length pack or a vari length pack or tag length value. And so by examining the UL, the decoder can figure out how to decode the value. And so when looking at these particular ULs, sort of searching the dictionary, we have to take into account that the value we pulled out of a file that we're looking for may not be literally present in the dictionary if it has a wildcard value within it. And we'll show an example of that a little later. In addition to being able to browse the published registers, there are also online development tools available only to members of the standards community. These tools allow you to submit requests for registration and to perform the maintenance necessary in order to keep those registrations up to date as your document progresses through the development process and even as it's maintained in publication. So we're going to now switch over to the register's maintenance site. And we're going to examine some end user use cases, which I've listed here. We're going to be doing browsing for entertainment. Hey, what's in that file? We're going to figure out how to go look for a UL that we are seeing in the wild, but we don't know what it is, and we want to figure out how we might react to it, especially, for example, if you're an end user and you have some software that's telling you a little bit or telling you that it can't find a number, you might be able to better communicate with your software vendor or with your development team if you are able to bring up relevant registers entries related to the error message that you saw. We can also find other ULs that are in the same family. This is especially interesting in the case of using labels and essence ULs. Typically, there is a range of these values that is appropriate for use in a given place, in a given context, and browsing them can likely lead you to standards that you might not be aware of. Then we'll talk briefly about how to register a UL and other tricks that we can perform. So with that, I'm going to switch over to my desktop. Looks like we made it. So this is the page that Bruce was showing you a little earlier, and we have a link here to the SMPTE metadata registry. So we are now out of the world of static pages. These are all dynamically generated from a backing database that understands the structure of all of the registers and all of the rules that are necessary to maintain compatibility for each individual value within the context of the register and the other values in that particular register. We're going to now be examining the three, two that are super interesting and one that we'll just point out, documentation. Of course, the team has been, just as they've been very busy with producing the software, they also produce quite a bit of documentation that I encourage you to browse if you have interest in this topic. This will help you to learn more about the registers themselves, the standards that define them, and also to learn about how to use this website and what its features are. However, the majority of our time we will spend looking at published registers. That's where we'll start. But then later on, we'll look at how the submissions area of the website can be used by developers of not just documents within SMPTE, but also developers of any MXF application that's using universal labels And in fact, I shouldn't even restrict it to MXF. There are several applications within SMPTE where KLV coding is used to encode information that's used, for example, in network protocols. So those same tools are useful in that context. So before I walk into the registers, are there any questions?
We do not have any questions at this time.
Okay. So we'll start with the.
This is Howard. It might be helpful to make your screen a little bit bigger, maybe if you can, just for those that must be on a small screen.
Your headset has entered matrix mode again, Howard.
Thank you.
It raises the hair on the back of my neck. Okay, so we are in the published registers area. This allows us to browse the register tables themselves. We'll show an example of that in a moment. It allows us to read an MXF file and generate a regXML representation of the metadata in that file. And it also, for those who are interested in historical information, you can look at previous versions of the registers. As I said, 30MR publishes these currently on an irregular basis, but we're moving toward publishing on a regular basis. So sometimes for troubleshooting purposes, it can be useful to go back and look at versions of registers that were in effect at the time a particular application was developed. And so all the previous publications are available here as well. So we're going to dive into the groups register because it actually is one of the smaller ones, and so it takes less time to load. These registers are actually fairly large, and loading them up in a browser, parsing them and making them available in the style sheet that produces the search function and generally pretty prints them for screen takes a little bit of time. We're going to use groups because it was the quickest to load. So as we can see, a register is essentially a list of universal label values. And each one of them has associated with it a symbol that is its human readable, I guess I wouldn't say doppelganger, but it's sort of the other side of the same coin. And so in the case of the groups register, as I said, we are listing a collection of universal labels that define groups, which are themselves data structures that contain other data elements within them. But we can see from here a couple of different things that are interesting. First of all, we can search by name if we happen to be aware of a name. For example, we learned it from a standard. We can search by UL. There is a defining document field. So I talked about browsing and being able to locate information that's relevant to your application that you may not have noticed otherwise. And then because the universal label data model itself is hierarchical and object-based, there's the concept of parent and child relationships, which are shown in here as well. But for the average end user who's looking through this for information related to an application they may have, it's really the labels that you might find most interesting, because it's the labels register that gives us the collection of values that are used all over our file formats to indicate essentially enumerated values and any kind of value that is meant to be uniquely identified and for which the definition of that identification appears in a SMPTE document or another documented resource. So right now I've kind of found myself down in the middle of an area where we have all the ULs that represent the various channel numbers that can be used in an audio channel labeling scheme that's been defined and is currently very popular in digital cinema and is required in IMF. So the tables themselves are kind of useful, but what's really interesting is to be able to browse for a file and look at its contents. We're going to look for a context file, plain text. So what's happening now is the browser is retrieving the MXF metadata from the front of that MXF file, submitting it to the backend. The backend is using the regxml library that we'll talk about in a little bit to decode those KLV packets, to look up all the values in the metadata registers, and then to encode the resulting expression as an XML document, which is functionally equivalent to the same metadata structure in the MXF file. So for those of you who are familiar with the contents of MXF files, we'll see all of our sort of familiar objects in here. That we have our package, and within the preface set, we have the identification list and the content storage object, which contains the material package and the source package. Bruce said we should mention UMIDs at least once in here. So at some point, I'll come to a place where here we have, not quite yet. There we are. There's a UMID. So I said UMID. Now I'm not going to talk about it anymore. So, so one of the things that might help you to read these files a little more easily is for me to point out that the UL values that are in here are encoded using what we call a URN encoding, which has there's a specific call out of that, of course, in a standard that says how this is done, but here's an example. So this takes the UL value, encodes it hexadecimally with the 3 decimal point separators, and then prepends it with the string URN SMPTE UL. There are other kinds of objects URN encoded in this as well. We have here's a UUID, and then oops, I mentioned it again. There's a UMID. Okay, I promise I won't mention UMIDs anymore. So if you have an MXF file that's giving you some trouble, or you simply want to look more into the detail of how it was coded and whether or not perhaps it conforms with standards, this is a very handy tool that you can go to parse that file into a form that will be much more easy to read than the KLV coding itself, and it will do so using the complete set of labels that 30MR considers to be accepted and properly documented and appropriate for public publication. I can stop for a question about the parsing tool if anybody has anything to ask about that.
And if we had a question, I would ask it for you.
Okay. So there are other expressions besides the conveniently formatted table for the browser. We can download the labels directly as XML, and I'll talk about how that can be used a little bit later. And we can also have a look at this hierarchically. There is, as I said, a tree organization, and so sometimes it's easier to locate information this way. I did mention that I would briefly look at where we find labels in the registers that are associated with entities not SMPTE. So we do have our set of organizationally registered for public use. So these organizations all have UL namespaces, if you will, assigned to them, into which they can create their own entries. And then we have a number of private ones that are registered by various companies that you'll be familiar with. Because these UL prefixes have their own unique values within the entire set of ULs within SMPTE, values that are registered inside of these groups can actually be published in the registers, give or take they're otherwise being compliant with the coding standards that are defined by the registers documents themselves and by regxml. So when a company creates an RDD, for example, or simply wants to submit to 30MR that they want certain values to appear in the registers, they go through the usual process of checking. They're entered into the database, and then they get published in the registers along with all the values that come from the various SMPTE documents.
So John, just to interrupt, can you describe a little bit shortly what the difference is between the public and private registers?
Sure. The main difference between the public and private registers is that I'm sorry, you mean between 13 and 14?
Yes, correct. Yeah, sorry. The registered by private or
Actually,
public.
I'm gonna volley that question to Bruce. I think Bruce is actually better equipped to respond to that than I am.
So basically, the Class 13 ones are for organizations that are bodies or trade associations like the EBU, like ATSC, SICTU, so these large bodies, and essentially they have slightly more process to manage their namespaces. And Class 14 is a private number space that you can manage and own and publish as much or as little of that namespace as you want. So these tend to be owned by major organizations who want to do special things inside MXF files or inside the number space.
Okay, thank you, Bruce. Does that answer your question, Howard?
Yes, it does. Thanks.
Okay, all right. So
just to say, John, we're at 1921, so you've probably got about another 8 3/4 minutes until folks might start having to drop off.
Okay. Well, in that case, I'm gonna move over a little bit to show. So I mentioned that the registers, in addition to being available in a browser-friendly format and in a hierarchical format, they're also available directly as XML. And one of the beautiful parts about that is that means that we can consume the registers in software and do things that would in the past have taken laborious entry of values from standards into software, or by conducting Rube Goldberg machines to scrape that information out of the old spreadsheet. So what I have on my window here, and someone will tell me if the text is too small to read. But what I'm showing is a JSON expression of another sort of parse of an MXF file that's also driven by the contents of the registers. But rather than using the regXML library, this is using a handwritten object parser written in Python, which I'll tell you a little bit later in the presentation, where you can go and see a description of that software itself. But here we see the exact same MXF objects. We have our, in this case, it's a little bit more data than what comes from the tool on the register's website, because we actually show the header packs as well. This is, I think, about 500 lines of Python is able to download the XML files and construct the internal memory structures necessary that it can read an MXF file and produce this result. So what I'm looking at right now is a time text track file. We can tell by coming down to the essence descriptor. Here we see that it contains a digital cinema time text descriptor, and it contains here we have a UL coded value. Here we have an integer coded value. Here we have a URN UUID coded value. So this object is a group. Its symbol, as we would see in the registers, is DC time text descriptor. The KLB key that you'll see actually leading the 16 bytes that lead this packet in the file is here. And then inside we have the various elements. So there's an element called sample rate, an element called instances ID, and so forth. So there's a UL that describes this packet, which is this UL. There's a UL that describes this member of this, which was not showing in this particular view. This particular element happens to have a value, which is a UL, so we contain, so that one's a UID, wrong one. Here, this one happens to have a value that's a UL, so here we have another instance of a UL in the file, which is not structural, but is instead informative, or descriptive rather. So another example that I wanted to show was if I tried to run this on a file that contains a slightly broken UL, I'm going to get an exception from my software that tells me that it's not able to find this particular UUID. Now, one way that I could look this up is I could select the back end of the value there and go back into my registers site, move into our friend published. I happen to have some intuition that that's a group. I'm going to search for that value. Oh, my intuition was incredibly wrong. I instead decide that it's going to be a label. In a future, more polished version of this presentation, I'll have the labels register in the background ready to use. Oh, it's not a label. It must be an element. So this is the slow way to sort of walk through the site and look at each of the individual registers, although I'm suddenly realizing a global search function would be really cool. We'll have to see if we can convince the developers to add that. Okay, so what we have here is a UL that decodes to the symbol data essence coding. So for some reason, this value here is different than the value that I have on the disk, and it seems to be that the difference is right here. Here we have a 3, and over here we have a 5. I happen to know through years of banging my head against this wall that this is the version byte, and version byte conflicts are actually very, very common in early interoperability efforts in digital or in MXF Exchange. People get a little bit out ahead while their documents are still under development and issue ULs into the field with a version that was provisional, and then suddenly they find that that has to change when the document is actually published. If you're interested in that particular project, I'd be happy to talk to you about it offline, about how we have changed our registration process so that that won't actually happen anymore. But this one is fairly old, and so this is still an issue. Now, as fascinating as it was to go through all of those registers, we actually can write a tool that looks through all the registers for us and understands concepts like version numbers out of sync. So, for example, can do a comparison without looking at the version number, and the tool can come and get us that answer much more quickly. So again, while it's nice to have an online resource where all these things are located, the very useful bit about this is that programs can consume these registers now and can perform activities that will not only be much more efficient to develop, but will be able to evolve over time as new versions of the registers become available to that software. And I have just a couple minutes left. I'm not going to be able to do a live demo of this. I had one prepared, but there are members-only areas of this feature, and one of them is the submissions area. There is a password required if you are a member of the standards community and you want to be able to access this area and you don't have the password. Please contact the chairs of TC30MR, and we will be more than happy to share the username and password with you. So what this section contains is the ability to upload and analyze a submission. And uploading and analyzing a submission is super interesting, because when you've done it, you can download versions of the registers in their XML form, for example, that include your submission. So not only can you do type checking, basic sanity checking, but you can also receive in return a set of registers that incorporate your changes. And so if you have a tool chain that's driven by the registers, you can then make these available to your tool chain and immediately test out what you know to be tested registers entries in the context of your actual tool chain. As a developer, that is, I can't tell you what an enormous time saver that is, and how useful that's going to be for the community. So just to quickly run back to my slides, dictionary-driven parsing is a topic that I've been spending a lot of time on lately. If you'd like to come to the Entertainment Technology 2018 conference, please come by. I'm doing a presentation that I think is an hour and a half long, where I specifically walk through that software and show how it works with the registers. And I'd be very happy to share as much information about that as people are willing to consume. We just went through the case of new structures and so forth. So I think also please be aware that the regXML project is a Java library that allows you to manipulate regXML in the context of the registers, produce your own registers, validate registers, and so forth. It's deeply embedded in the website that we just looked at. And there's also a partial implementation in C++ that's useful for deploying in implementations. And I think I'll leave it there because it looks like we're out of time. Thank you very much for your attention.
Outstanding. Thank you, John. I suppose we should ask people if there are any questions for John, because that's an awful lot of information to take in one go. And I suspect that John is talking into mute.
Yeah, and I also think it's a good time to, maybe we'll pimp the Entertainment Technology Conference that's coming up in June that John was talking about. If you're not aware of that, you can certainly go to the SMPTE.org website and learn more about that event that's coming up. But that should be a really good event coming up. It's going to be in the Silicon Valley, and John will be giving an hour and a half of his time. And more important, you can hit folks up in the networking time, which is really the best time ever. So.
And we've got speakers from Microsoft and Google and Facebook and all sorts of fun places.
Yep.
And Bruce, we are starting to lose some of our guests, so anytime you're ready for the poll, I'm happy to launch it.
I think let's put the poll up. If there's no questions for John, let's stick the poll up. And if you're still on the line, folks, please punch in your response. For the next webcast, would you like us to have a broad look at high dynamic range and wide color gamut, at the SMPTE 2110 ecosystem, or the IMF ecosystem?
Oh, I see.
And if there's a tie, I will choose a subject I know about.
I so wanted to vote. They won't let us vote.
I know.
Yeah.
Bad boys. We know which one you and I would vote for. It's quite easy.
Yeah, probably. Or do you?
Or do you? Absolutely. Actually, it's much more fun hearing us speak about things we don't know about.
That's right.
Makes the audience questions more interesting. Did you really mean to say that, Bruce? Howard? Are you talking rubbish?
Quite possibly.
Quite is.
And I think the number of responses are slowing down.
And a big thank you to everybody who has stayed on for the full 90 minutes.
Yeah, I'm quite impressed that we had this big of a crowd on a spring break week, heading towards NAB as well, and Easter. So,
whoa, look at that for a result.
Of course, split again. Oh, damn, our 33 thing.
I do have to tell you that one gentleman has said HDR in the question area, and another person who had signed off said HDR before he left.
Looks like HDR is the winner then. I think we're going to have to find us an HDR expert to come and help guide us along on this one. So, Joel, if you're just able to put up the final slide, which talks about the next SMPTE meetings coming up, that would be lovely. For the last few people who just happen to be here, or do I have control? There we go. So the next SMPTE Standards meetings are at Ryerson University, week beginning the 18th of June. After that, we're in Geneva after IBC, and then Dolby's hosting us in December. March, we're probably going to be in the USA, and it's looking increasingly likely that we will be in Japan during June 2019. So not this coming June, but the June after that. So truly global society. Things are looking very interesting. And don't forget that you can download all the meeting reports. Joel will make these PowerPoints available. We've got a master calendar that tells you where everything's coming. And you can listen to this again at YouTube, and you can write into svp@simpte.org and dura.standards and tell us all the things that we got slightly incorrect, because I know how much that makes you all happy.
Any closing comments, gentlemen?
Just to thank the audience. Thank you.
Yeah.
Thank you all very much.
And thank you, John, for your presentation on the registers. Very helpful, I think.
Absolutely.
I learned some things.
Yes, thank you, John. Thank you, Howard. Thank you, Bruce. Thank you to our guests. Hope we will see you next time on a SMPTE webcast. And take care. Safe travels. We'll see you next time. Bye-bye.